Gear teeth are essential components of many machines, transmitting power and motion between rotating shafts. For gears to mesh correctly and function efficiently, the teeth must be manufactured and measured with high precision. Accurate gear tooth measurement is crucial for ensuring proper gear performance, preventing premature wear, and avoiding costly failures. A specialized tool called a Gear Tooth Vernier Caliper is commonly employed for this purpose. This essay provides a comprehensive guide to understanding gear tooth measurement using a Vernier caliper. We will delve into the intricacies of this essential tool, explore the step-by-step measurement process, and highlight common pitfalls to ensure accuracy. By the end of this essay, you will have gained a thorough understanding of gear tooth measurement, enabling you to confidently assess the quality and precision of gears in various engineering applications. A Vernier caliper is a precision measuring instrument used to obtain accurate linear measurements. Scale with a fixed jaw and a sliding Vernier scale with a movable jaw. The Vernier scale is calibrated with slightly smaller divisions than the main scale, allowing for measurements to be made with greater accuracy. When the jaws of the caliper are closed, the zero mark on the Vernier scale aligns with the zero mark on the main scale. As the jaws are opened, the Vernier scale slides along the main is read by observing where a mark on the Vernier scale aligns with a mark on the main scale. Vernier calipers are versatile tools used in various fields, including machining, woodworking, and engineering. Useful for measuring the dimensions of small objects and for making precise internal and external measurements. A vernier caliper typically consists of the following components: outer jaws, used to measure external dimensions, such as the diameter of a shaft; inner jaws, used to measure internal dimensions, such as the diameter of a hole; depth probe, used to measure the depth of a hole or slot; main scale, graduated in millimeters or inches, providing the primary measurement reading; Vernier scale, a sliding scale with finer graduations that allows for more precise measurements; retainer, a screw or lever that locks the sliding jaw in place, ensuring accurate readings. Understanding the function of each component is crucial for using the Vernier caliper effectively and obtaining reliable measurements. Accurate gear tooth measurement is paramount in ensuring the proper functioning, efficiency, and longevity of gear systems. Precise measurements are critical for proper gear meshing, as accurate tooth profiles ensure smooth and efficient power transmission between gears. Minimizing wear and tear is also essential. Well-measured teeth distribute load evenly, reducing wear and extending gear life. Noise reduction is another benefit, as precise tooth geometry minimizes vibrations and noise during gear operation. Preventing gear failure is crucial too, with accurate measurements helping to avoid tooth breakage, stripping, and other failures. By ensuring accurate gear tooth measurements, engineers and technicians can optimize gear performance, reduce maintenance costs, and prevent costly downtime. To measure the thickness of a gear tooth using a Vernier caliper, follow these steps. 1. Select the appropriate caliper. Choose a Vernier caliper with jaws wide enough to comfortably accommodate the gear tooth. 2. Zero the caliper. Close the jaws of the caliper completely and ensure that the zero mark on the Vernier scale aligns with the zero mark on the main scale. 3. Position the caliper. Carefully position the outer jaws of the caliper perpendicular to the tooth surface, ensuring that both jaws make contact with the tooth flanks. 4. Apply light pressure. Gently close the jaws until they lightly grip the tooth, avoiding excessive force that could damage the caliper or the gear. 5. Lock the sliding jaw. Tighten the retainer screw or lever to secure the sliding jaw in place, preventing any movement that could alter the reading. 6. Take the reading. Observe where a mark on the Vernier scale aligns perfectly with a mark on the main scale. The main scale provides the whole number measurement, while the Vernier scale provides the decimal fraction. 7. Record the measurement. Note the measurement reading, ensuring that the units are consistent with the caliper's calibration. By following these steps meticulously, you can obtain accurate and reliable gear tooth thickness measurements. Section 6. Tips for enhanced accuracy. To enhance the accuracy of your gear tooth measurements, consider these practical tips. Cleanliness is key. Ensure that both the caliper and the gear teeth are free from dirt, debris, or burrs that could affect the measurements. Temperature stability is important too. Allow the caliper and the gear to reach room temperature before taking measurements, as temperature variations can affect the accuracy. Apply consistent light pressure when closing the caliper jaws to avoid introducing measurement errors. Take multiple measurements at different points along the tooth and calculate the average to minimize random errors. Periodically check the calibration of your vernier caliper to ensure that it is providing accurate readings. By implementing these tips, you can significantly improve the reliability and precision of your gear tooth measurements. Section 7. Common mistakes and how to avoid them. When measuring gear teeth with a vernier caliper, it's essential to be aware of common mistakes that can lead to inaccurate readings. Avoid parallax error. Avoid viewing the caliper scales at an angle, as this can cause parallax error. Always ensure that your line of sight is perpendicular to the scales. Be cautious of excessive pressure. Applying too much force when closing the jaws can deform the caliper or the gear tooth, resulting in inaccurate measurements. Ensure that the caliper jaws are perpendicular to the tooth surface to avoid measuring the chord instead of the true thickness. Double-check your reading of the Vernier scale, paying close attention to the alignment of the marks. By being mindful of these common pitfalls and taking appropriate precautions, you can minimize errors and obtain accurate gear tooth measurements. Section 8. Applications in engineering and beyond. Accurate gear tooth measurement is essential in various engineering disciplines and industrial applications. Some notable examples include automotive engineering, ensuring precise gear tooth dimensions in transmissions, differentials, and other automotive components is crucial for optimal performance, fuel efficiency, and reliability. In the aerospace industry, accurate gear tooth measurements are critical in aircraft engines, landing gear systems, and other aerospace applications where precision and reliability are paramount. Robotics rely on precise gear systems for movement and manipulation, making accurate gear tooth measurement essential for their accuracy and repeatability. Manufacturing processes often involve gears, and accurate tooth measurements are crucial for ensuring product quality and consistency. The ability to accurately measure gear teeth using a vernier caliper is a fundamental skill for engineers, technicians, and anyone working with gear systems. Section 9. Conclusion. Ensuring precision in gear systems. Mastering the gear tooth vernier caliper experiment is essential for anyone involved in the design, manufacture, or maintenance of gear systems. By understanding the principles of vernier caliper operation, following the step-by-step measurement process, and implementing tips for enhanced accuracy, you can ensure the precision and reliability of gear tooth measurements. Accurate measurements are crucial for optimizing gear performance, minimizing wear and tear, preventing failures, and ensuring the smooth operation of countless machines and devices. By embracing the principles outlined in this essay, you can contribute to the efficiency, longevity, and overall success of gear systems in various engineering and industrial applications.